Okay, sir.
Farabi. Hello, Farabi. Farabi,
Sir, बोलना
please read this learning outcomes.
learning outcome. Candidates should be able to A. Describe the production of sound by vibrating sources. Describe the longitudinal nature and sound waves and describe compression and rarefaction. State the approach of audible frequency for the healthy human ear as 20 Hz to 20,000 Hz. Explain why a medium is required in order to transmit sound waves and describe an experiment to demonstrate this. Describe a direct method for the determination of the speed of sound in air and make the necessary calculation. State the order of magnitude of the speed of sound in air, liquids and solids. Explain how the loudness and pitch of sound waves relates to amplitude and frequency. Describe how the rarefaction of the sound may produce an echo. Describe how the shape of a sound wave, as demonstrated by an oscilloscope, is affected by the quality of the sound wave. Describe ultrasound. Describe the uses of ultrasound in cleaning, quality control, and prenatal scanning.
So about sound, so far I understand you have this idea that audible frequency, right? This one you know before, isn't it? 20 hertz to 20,000 hertz, and more than 20,000 hertz, less than 20 hertz we cannot hear. More than 20,000 hertz is called ultrasound. Okay, and other things also, you know, like compression and rarefaction. Already we got in topic 13. There we got compression and rarefaction. We got longitudinal sound, right? Longitudinal wave definition. So sound is one kind of longitudinal wave. In sound we have compression and rarefaction, and energy transfer direction is parallel to the vibration of particles. And also, you know, sound is one of the mechanical waves, because sound requires medium to travel, and we will know if the medium is different, like air, liquid, solid, then the speed of sound is different. We know about frequency, we know about amplitude, and that one we will relate with sound now. Loudness, how loudness is related to amplitude, and how pitch of sound is related to frequency. Okay, and echo, we have another term related to sound. If we produce sound and if it reflects back, then we say it echo, reflection of sound. And sounds, ultrasounds uses, you know, this one is very much familiar with us, that ultrasound imaging, right? You know this one, right? Prenatal scanning. Most probably you all were scanned by this ultrasound when you were in mother's womb, right? Isn't it?
Yes, sir.
Yeah, so we will try to understand all these things. Now, production of sound by vibrating sources. Okay. Here you see compression and rarefaction. Huh? Then sound waves are longitudinal waves. So these three we first discuss. First one is production of sound by vibrating sources. So you write this heading, production of sound by vibrating sources. Everyone write this heading. Then Monica, you read activity 1. Monica, Monica is not there, right? Disconnected maybe. Then Mahi, you read activity 1.
Okay, sir. Hmm, Activity 1. Take a tuning fork and set it vibrating by striking its prong on a rubber pad. Bring it near your ear. Do you hear any sound? Touch one of the prongs of the vibration tuning fork with your finger and share your experience with your friends. Now, suspend a table tennis table or a small plastic ball by thread from a support. Take a big needle and a thread, put a knot at one end of the thread, and then, with the help of the needle, pass the thread through the ball. Touch the ball gently with the prong of a vibration tuning fork. Figure 1. Observe what happens and discuss with your friends.
So here we are having the sound from a vibrating tuning fork, right?
Yes, sir.
And we are now doing this experiment with table tennis ball. And if we bring this closer to the table tennis ball, then we'll see as the tuning fork is touching the table tennis ball, the ball is also vibrating, right? Hello.
Yes, sir.
So this is one sort of proof that sound wave we are getting from the tuning fork that is coming by vibration. Okay. As the ball is vibrating, so this vibration came from the tuning fork. We get the sound also by this vibration. So can you continue here? In the above activities. Yeah, Mahi, continue in the above activities. Continue.
Okay, sir. In the above activities, we have produced sound by striking the tuning fork. We set the objects vibrating and produce sound. Vibration means a kind of rapid to and fro motion of an object. The sound of the human voice is produced due to vibrations in the vocal cords. When a bird flaps its wings, do you hear any sound? Think how the buzzing sound accompanying a bee is produced. A stretched rubber band, when plucked, vibrates and produces sound. If you have ever never done this, then do it and observe the vibration of the stretched rubber band.
So you wrote this heading, right?
Yes, sir.
Production of sound by vibrating sources. So now you write only this part from here. Huh? Okay, write only this part, huh?
Okay, sir.
Farabi, hello Farabi. Farabi, are you
Yes,
writing?
yes, sir.
Please write that one I marked. You write that part only. Are you done?
Sir, almost.
Yeah, do it. Write only the mark part, not everything. Till the vocal cords.
Okay, sir, done.
Farabi, are you done? Hello, Farabi,
Not
are you
yet.
done?
Not yet.
Yeah, do it. Till the vocal cords, okay?
Sir, done.
Hmm. So now you write this heading compression and rarefaction. Eh? Write this heading compression and rarefaction. Then Farabi, you read this part from here. Sound waves are
Sound waves are characterized by the motion of particles in the medium and are called mechanical waves. Air is the most common medium sound through which sound travels. When a vibrating object moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. This region called a compression C, as shown in figure 16.2. The compression starts to move away from the vibrating object. When the vibrating object moves backwards, it creates a region of low pressure called rarefaction, as shown in figure 6.2. As the object moves back and forth rapidly, a series of compression and rarefaction fractions is created in the air. This makes the sound wave that propagates through the medium.
continue.
Compressions are the regions where particles are crowded together and represented by the upper portion of the curve in figure 16.3. The peak represents the region of maximum compression. Thus, compressions are regions where density as well as pressure is high. Rarefactions are the regions of low pressure where particles are spread apart and are represented by the valley, that is the lower portion of the curve in figure 16.3. See, a peak is called the crest and the valley is called the trough of a wave. Trough. The distance between two consecutive compressions C or two consecutive rarefactions R is called wavelength, as shown in figure 16.3. The wavelength is usually represented by a Greek letter lambda. The SI unit is meter m.
Okay. Now you draw these two diagrams. These last two diagrams. And you label here compression for C, rarefaction for R. Okay, and this crest, we know about crest and trough, right?
Yes,
Yes,
sir.
sir.
So compression starts with C and crest also starts with C, right? isn't it?
Yes, sir.
So crest for compression and trough for rarefaction. You see the way it's drawn, you draw also same way. Where it is rarefaction, there is trough. Where it is compression, there is crest. Okay,
Sir, which one should we draw?
these two, last two. This is
Okay, sir.
thicker one and density or pressure, then all these things you label. Huh?
Okay, sir.
Last two diagrams. Label nicely. Then you write here after drawing. Don't write everything, just write the one I'm saying to write. Yeah, here compressions are regions where the density as well as pressure is high, and rarefactions are the regions of low pressure where the particles are spread apart and represented by the valley. Particles are spread apart till here, right? Yeah. Are you done with writing?
Yes, sir. Not all.
And drawing is done?
Yes, sir.
Sir, I'm doing the drawing right now.
Yeah. Do the drawing and then write this marked part. Okay.
Okay, sir.
Do it fast. Monica, Monica, hello, Monica. Monica,
Yes, sir.
Yeah. Write the heading compression and rarefaction. The spelling is here compression and rarefaction. Have you written the topic name? Topic 16
Yes,
sound.
sir.
So you all are done, right? Mahi?
Sir, I'm writing the notes.
Yeah, write quickly. We have 1 minute left. Farabi, are you done with drawing and writing?
Yes, sir. Yes, sir.
Okay, very good. Then you join after 10 minutes, Farabi? Join after 10 minutes. Then you wrote, Monica, this heading, compression and rarefaction.
Done.
Yeah. So all of you join after 10 minutes,
Okay, sir.